Alright, so finally, we actually get down to see if our results are actually significant. Is the variance between these groups actually significant? So, first of all, we need the degrees of freedoms within and between. And we need that to be able to read our F critical value table. And I'll bring that up in a second. First of all, we remember our between degrees of freedom was 2, and our within degrees of freedom was 6. Now, to read the table, we need to know the numerator degrees of freedom and the denominator degrees of freedom. So in this case, for F, our numerator is between and our denominator is within. This is always going to be true. So our denominator is 6 and our numerator is 2. So now let's take a look at the table. So you see here we just have sort of a table here of rows and columns, and we need to find the sort of critical point. And this is the critical value of F at probability of less than 0.05, which is generally considered statistically significant. And that's what we're going to use for this case. So let's find our actual critical value. So our numerator, again, was 2. So we're going to find column 2, and our denominator was 6. So we find row 6. So 2 and row 6. So under these circumstances, anything higher than 5.143 is considered statistically significant. So we know it's actually, it'll be less than 0.05 because we're looking at 5.143. Now, because we're still so far over that number, our F ratio is 12. So far over the number, we could see if we can actually isolate that even further, see if it's even more statistically significant than we actually thought. How you would do that is come down and look at the F ratio that is equal to 0.01, meaning there's only a 0.01 chance of the numbers falling the way they are, that the variance being explained by anything else, or actually would be happening randomly rather than there being an actual reason for it. So we could take a look at this, right? So we do the same thing. The numerator is a 2, the denominator is a 6. So we go 2 down to 6, and our critical value is 10.925. We're at 12. We are still more critical than the critical value, meaning that our probability, that's that little funky symbol right there, that's what that means right there. Our probability is equal to, or really in our case, is less than 0.01. Highly statistically significant number, or highly statistically significant analysis. That's how we would end up explaining this. So for the last part of your homework, you need to come to this table in your book and actually look for the critical value. If your value is higher, then you have a statistically significant data set. And what that would mean is that we can reject the null hypothesis, that in some sort of random situation these numbers would fall in line, and we can accept the research hypothesis, whatever that is. In my case, it's really nothing because we're just using numbers. But we could be looking at the variance between, say, 3 groups of people. We could say freshmen, juniors, and sophomores in any respect. And these are test scores. And we want to know if the variance in their test scores can be explained by their categories, the categories that they are in. So if we assumed, again, I think I said that out of line, let's say freshmen, sophomore, juniors, right? The juniors in this example would be scoring higher. Well, that's all fine and dandy. We have a mean of 6, and of course we can say common sense, yeah, they do better. But does that variance actually mean anything? That's why we run analysis of variance, to come up with our F ratio, and then look at the critical value of F and see if it's statistically significant, if these numbers are simply random, or if the variance between them actually means something. That's it for this section, and I'll try to post some more videos to help y'all out on y'all's other homework assignments. Please email me with any questions you might have. Post to Ask My Professor. If something in here wasn't particularly clear, you want me to highlight or expand on a particular issue, please let me know.